Okay, so after we have done all the cleaning, we have looked at the data, we have got our training set, testing set, cross validation set. We have even confirmed whether my distribution is appropriate or not. Now, after this, we need to go back and see that what is the criteria based on which Kaggle is going to decide that who is going to be the final winner. Now, for this, we have to again go back to Kaggle page. So I'm going to go on the top, click on this Kaggle link once again. Now, when we are going to look at this, you will notice here there is something called as evaluation. Now, let's click on this. And this is where you need to see that what is the criteria they have kept it. Now you can see here that they have clearly mentioned this is going to be evaluated on multi-class log loss. Okay. Now you might have heard about various ways of evaluating a model. For example, you do have something called as accuracy, right? This is a very common metric being used. You have something called as AUC, area under curve, ROC. So many things are there, right? So many evaluation metrics are there for my model. But in this case, Kaggle have kind of restricted you to multi-class log loss. And this is how your Kaggle competitions go different from your real world corporate problems. In the corporate problems, there is nothing like this, that you have to only look at one particular metric and give the output. You need to be kind of generic, but Kaggle being a competition have to definitely go in a way so that they can easily identify that who is the winner. Now, this log loss, if you don't know about it, don't worry about that. I'm gonna give you a good explanation of what is log loss, because I know that most of the instructors generally don't teach this metric. If you know it, well and good. You can skip out this particular lecture because this lecture is going to be completely about log loss. But if you don't know, then you will learn that even from this problem point of view, what are the things in log loss you look at. So we will understand this particular point and how this log metric is important. So maybe I would keep two metric here. One is your confusion metric because that's what you guys understand well. So I'm also gonna consider confusion metric so that you can understand the accuracy portions and all that quite well. At the same time, we will also understand from the log loss point of view, because the winner is gonna have the minimal log loss. So here, like we always say that this, right? We want to keep the error to the minimal point in machine learning. So similarly for log loss, we want to keep the log loss to be minimal because that's what would be our evaluation criteria here. So that's what we're going to learn now. So let's understand that what is first log loss, and then we will relate to our problem statement that how this is going to fit in this log loss formula here. So let's go back and understand this now. So this is going to be log loss. Okay. So in order to understand this log loss, let's take a very simple example. Okay, so let's say I have input X. Okay, and I do have the output Y, and let's assume that this is a binary classification problem. So let's say for my input X, there is something like X1. In fact, let me mark it with different color, and let's say my original output for this is 1. X2, this is also 1, X3, this is 0, X4, this is 0. Let's say this is my outputs. Now here, let's say when I build a model and I got my prediction Y dash, okay, this is probability. Let's say my probability came out to be, let's say we have built a model that anything greater than or equal to 0.5 probability, I'm going to mark it as 1. Otherwise, I'm going to mark it as 0. Let's say we have built some model like that. And for the first portion, let's say we got it our probability as maybe 0.9. Second one I got 0.6. Can you see that it's a close decision because we have just a probability greater than 0.5, so that's why we have considered it. Third column is, let's say, 0.1. This is good for predicting it to be 0, but let's say 1 is 0.4. So if you look at this part, this is, let's say, 0.4. Now let's say these are the probabilities, and based on this you have done your predictions. Now if you go with the your accuracy metric, and if you have built something like this, then in that case your accuracy will come out to be almost 100. right? So that's what you would say, that my prediction and my final output is quite good. But log loss kind of work in a little different way. Let me first explain you the formula behind this log loss so that you get an understanding that how it works. So in order to get the formula, I will explain you how this formula also work, but for now just let me note down this formula, log loss. So for the previous data, first of all, it's going to be minus, okay, minus 1 by n, okay, means I'm going to take the average. So if I have in the previous, I have 4 rows. So my value of n is going to be 4 in that case. I'm going to run this from 1 to n, okay. And what I'm going to do in this case, I'm going to take up the log values. So I'm going to say log of probability, okay. So this is going to be probability, which is pi, okay, which we got like 0 0.9, 0 0.4 and so on, into my yi. Basically this is my original output what we had. Now this is first thing, plus 1 minus yi. So in between both of them, only one of them is going to be true. So if the value is 1, then this value will become 0, right? So only this term will make sense. And then log of 1 minus pi, which is again the probability, okay? And this. Let's once you go through this full formula, you will get a good insight that how this whole thing works. Now, as I said, with this part, this is for a binary classification, very specific to our old data, which I have presented to you here. So if you look at it, we do have the knowledge of yi, we do have the knowledge of our probability part like pi. So with this, we're gonna place our data to this. Now, if I look at this y is equal to 1, right? So if I have to place this data into my formula, so since I have a minus symbol, I can maybe put my minus inside and let's start solving it up. So my first value will become what? Minus log of pi. Pi is what? 0.9, right? So first row, I have the probability of 0.9 into yi. Yi is what? 1. So I got this value. Now, what about this part? 1 minus yi. So since the value is 1, so 1 minus 1 will become 0. So this term will become anyway 0. So it doesn't matter what is going to come out here. It's always going to be 0. So I got the first term for the first row as minus. So I'm going to note it down here. So minus log of uh, basically I'm going to get minus log of 0.9. This is for the first row. Let's calculate it for the second row also. And if you do calculate again, this is for yi as 1. So my 1 minus yi will become 0. And if you look at it, I will get minus log of 0.6. This is for the second row. For the third row, let's go back. This is for yi as 0 and yi dash is 0.1, right? So again, let me go back and plug in into this formula. And if I have to plug into this formula again, it's going to become, so I'm kind of ignoring 1 minus n term, which I can always include at any moment. This is just for an understanding. I'm trying to explain what is log loss. Now, after this, if I plug into this formula for the third row, so definitely this term, because yi is 0 will become 0. So only this will be kind of relevant right now. So 1 minus 0 will become 1. So 1 into log of, again log of. Now this is 1 minus pi and pi is 0.1 for this. So it's become 0.9. Okay. So this is what the value we're going to get for the third row. Let's go back and place it here. Minus log of 0.9. And same way, if you compute it for the last row, I will get minus log of 0.6. If you do compute these values, I have done it already, so you need not worry about that. So if you do compute all this value, your values for minus log of 0.9 is going to be 0.0457, if I'm not wrong. This is going to be 0.22 and this is going to be 0.0457 and the last one again is going to be 0.22. Now let's look at the interesting point here. if my probability is 0.9, which is kind of high for value prediction to be 1, means if you get like probability of 0.9, and if I'm predicting okay this is going to be 1, that means it's a good prediction. My probability is kind of coming quite good. But if my probability comes out to be 0.55 and I'm predicting it to 1, there was still a dilemma. It could have landed to 0 even position, right? Because it could have kind of gone lesser than 0.5 and we could have gone to 0. But being this, basically this is very close to my 1 and it's a very good prediction for this row. So can you notice that this value comes out to be very low for this? If my prediction is quite good, my log loss value is going to be low, because as I told you, my log loss should be as minimal as possible. Now, if this is the second part, can you see this 0.6 probability? Here, my this value came out to be high. So when there was a dilemma, my log loss is going to penalize me. It's going to say that, okay, my this value is huge, so I'm going to give you the value of 0.22, which is high. Similarly, look at for 0.1. This should give you a low log loss value. Why? Because again, this is very good probability for my zeroth value. So you can notice this. I got 0.04, which is a quite low value. But for 0.4 to prediction 0, it should again return me a little high value. This is the whole idea behind log loss. So the main idea here is that more your prediction is better, the log loss value is going to be low. If your prediction is going to be kind of ambiguous, it's not that great, then your log loss is going to penalize you. So we want to keep this whole value to be lower. That's what is the whole idea behind this log loss. You can think about it. Let's say I have this probability as 1 instead of 0.9. Then in that case, what I will get? Log of 1, right? And log of 1 is what? 0. If I get log of 1 as 0, that means my log loss became 0, right? So if my probability somehow goes to exact 100%, that means I will get my log loss as 0 value. So this is the beauty behind this. Now I can extend the same thing to my multi-class classification example as well. So right now we understood from the binary classification part, but I can extend it to completely multi-class classification. So let's go and try to put the same thing into my multi-class classification. So for my multi-class log loss, the scenario is that I'm going to say 1 minus n. I'm going to run it again for all the rows, but this time I'm going to put it for my classes basically from 1 to C. And here I'm going to put Yij, which means that it's going to be 1 if my Xi, so it's going to be equivalent to value 1 if my Xi belongs to class J, right? So if this is the part, it's going to be 1, otherwise it's going to be 0. Again, just go back again to the same binary classification. If you want, you can just change this value of C to 2 and I give this as a homework activity. It will just end up to the same solution what we have just gone through. I would suggest you to do that. Now after that we can just say log of Pij, which again is the probability term that Xi belongs to class J. Okay, that's a probability what we have. Now this is the formula which we can put it if we are talking with respect to our multi-class. Now if we come back to our case study, we are talking about multi-class. We are not talking about single class, we are talking about multi-class problem. So let's understand that how in our multi-class scenario, how this is going to fit in for our project. Now, again, as I said, this is basically telling me that yi belongs to class J. So if you think about it, let's say in my project, we do have 9 classes, right? So let's say there are 9 classes. Now in this 9 classes, let's say I have this value as 0, 0, this is 1, and again all the value as 0. So this is, let's say, y for ith row first classification. Again, this is y ith row second classification, yi3, right? So which is for ith row third, this class third. So let's say this is belonging to 3. So in this case, we can say that this value is going to be 1 for ith row where it's belong to class 3. So that's how we kind of represent it. Now in terms of probability, if we look at in terms of probability, if we go and kind of understand this, I have a data set, I'm passing it to my model, and I will get some probabilities. So my probabilities will look like this. I will have, let's say for first row, if I'm talking about, okay. So I do have, let's say first row, and this belongs to class 1. This is the probability for it. Probability that first row belongs to class 2. Again, you can keep on doing it till class 9, right? Because we have 9 classes. Now, think about it. Just put this in this way. Let's say I got a probability that for class 3, the value is 1. Okay. For remaining, it is 0. So what I'm saying that maybe I am getting a probability that for 1, 2, 3 till 9. So if you look at it for remaining output, because sum of the probability should be 1. So what I'm saying is that let's say we come to a situation where I got an output from my model from when we passed this. We got an output that probability comes out to be 1 here for this. Now in this case, if you will calculate the log loss, you can just go back to a formula and put it. You will get basically log of 1, which is going to be 0. So I will get the log loss to be 0 in this particular row. For this row, I will get the log loss as 0, which is quite good. But in case, let's say this is 0.9, okay, instead of this, let's say this is 0.9 and I got this as 0.1 and remaining as 0. Now in this case, my log loss is going to penalize me. This 0.9 will return me a very lower value, as we have seen it in the binary classification as well. But at the same time, this is definitely going to give me some value greater than 0, right? So my log loss will have some value. So the best model for log loss definitely should be 0. The value for log loss is 0. That means I'm creating a perfect model. But in real world, we never have a perfect model. So in this case, the model can lie from 0 to infinity. So we will see that how to use it and how to build the model with the log loss keeping in mind. But this is what log loss is all about. So we just understood what is log loss. We will see to the next lectures that how to use it.